Thanks, Larry. Yeah, so today we have the Ramp School of Audio presentation by Norman Varney. Norman has an extensive background in engineering, as well as not just the room treatment aspect of taking care of sounding your room, but what we're going to be talking about today, which is noise and vibration control, which I think is extremely underrated when we're looking at how we interact our systems with our rooms and our environment. I find myself, more so than any of these boutique exotic fuses and fancy schmancy cables and all the other stuff out there that people use as tone controls, I find actually that the noise and vibration control is probably the most realistic and most bang for your buck that you can get out of any tweak that you can do to your system. And next after that, to me, would be obviously something that's going to be talked about on November 18th with Manny Lacaruba. But it is actually then treating or EQing your room, depending on your preferences. So again, that event will be November 18th live in Orinda, California. And Manny will do a presentation. He'll talk a little bit about, room EQ, and then basically do a demonstration where you could hear the room un-EQ'd and then the room EQ'd, so you can hear for yourselves the difference. But for today, I'm going to turn it over to Norman Varney, and he's going to continue along with his presentation on noise and vibration control.
All right. Well, thank you so much. I'm delighted to be here and to present this. And I really enjoy doing this, and especially enjoy at the end the real world questions that you guys have and addressing those. So it is jam packed, and so I'm going to jam through it pretty quick. And so, yes, hold up on the questions, write them down, put them in the chat, and we'll address them later on. But I am going to go through this pretty quick because of the time involved. Let me get to share screen. Okay, and from the beginning, yeah, there we go. Am I good? Can people see me, and do people see a full screen of the presentation? A thumbs up?
Yeah,
We're good.
Looks good, Norm.
Yep.
Okay. So let's see. Okay, so we're going to be talking about noise and vibration from an audiophile's perspective. And so we're going to cover what the fundamental sound quality attributes are for critical listening. And we're going to talk about how far off the typical listening environment is from what we desire. And we'll talk about why we have points of, what those points of desire are and why, and what those attributes mean to the experience. And we're going to talk about how these sound quality characteristics are measured and solutions to these common problems. So we're talking about fundamentals here, and we're going to break this into kind of two segments. I'm going to talk about acoustics, and I'm going to talk a bit at the end about the electrical, our power supply and power quality. Those two things in my mind are the building blocks, the foundation, the fundamentals of putting together a good playback system. And if we don't have those in place, then we're not going to achieve the full potential of our equipment, of our investment. So I may be getting ahead. Oh, so there's a hierarchy regarding this. We're going to be, I think often audiophiles will do some fine tuning before they really have the course adjustments in place. There's always a hierarchy. And when we mess with one, we're probably messing with something else, attributed to it, like video calibrations. When you make an adjustment to the brightness, you're making an adjustment to the contrast, and vice versa. So these changes, these tweaks that we made, they affect other areas, and we want to make sure that we are understanding what we're doing and that we are doing them in a proper order so that we understand and aren't getting confused and chasing our tail. So we're often talking about specifications, and as audiophiles, we're very familiar with specification, spec sheets, and we're looking at frequency response measurements of speakers, or we're looking at total harmonic distortion of an amplifier, or some of these things, like THD, 0.006 or something that is really small. Frequency response, we're looking at anechoic responses of these speakers that are, what are they, plus or minus 3 dB. They're fairly meaningless specifications compared to the specifications that are very meaningful, meaning that frequency response curve for that loudspeaker doesn't really tell you much. It doesn't tell you about propagation in the room. It doesn't tell you about the tonal characteristics of the loudspeaker at all. The THD, can't hear it. So they're fairly meaningless compared to others. For example, do you know what the ambient noise floor is in your room? This is an important and meaningful specification that you should know. Everybody should know, and probably very few of you know. Do you know what the reverberation times are of your room? Every reverberation curve of all of our rooms is different. And that's not what we want. We want to have control over these things. And there's a goal, there's a curve that we're looking for so that we have neutrality and we have consistency and we have repeatability, not to mention great performance and a wonderful experience. Do you know what your ground impedance is? Again, a simple specification that's important. So this is my big, bold statement. I would say that more than 90% of the audiophiles are experiencing less than 50% of their equipment's potential. And I'd say that's probably conservative. Why is this? I think there's several reasons for that. I think there may be inexperience as to the audiophiles may be inexperienced as to the potential. Like we talked about before we were actually on air. With acoustics, especially, it's very hard to explain in words what the difference is, and you really have to experience it before you can really understand that. We are all at different levels of reference. We all have a system that we think that was the best thing I've ever experienced. And somebody else has maybe one that's a little higher than that this person has never experienced. Well, until we've experienced it, we really don't understand. And I think they may be unaware of the obstacles that are preventing a better experience, and we'll talk about those. And they may not know how to control these obstacles. And there may be constraints preventing them from achieving their goals. There always are. In our rooms, they're rooms, and they're always, no room's perfect. They're all going to be unique as far as the constraints that there are. And those constraints, they can be physical or decor or budgetary or time constraints or on and on. And then also they are told that the answer is to buy better equipment, right? That's typically what what we get is, to get to audio nirvana, I've just got to replace this cable, or I've got to get a new preamp or something like that. That's typically the answer, right? But that's not going to do it. It's not just understand the equipment can't control the acoustics. So what are the audiophiles doing in the meantime? So this chart on the left-hand side of verses is the typical action taken to improve the audio experience by the audiophile. And to the other side of verses is the typical impact on the audio experience to the audiophile. Now, if you look at these, you'll see, most people are getting new equipment, they're doing upgrades, they're doing tweaks. They're not really addressing passive acoustics like interior acoustic treatments or the physical setup, vibration isolation and resonance dampening. And if you look on the right-hand side, it's almost an inverse, right? So on the right-hand side, what's going to have the most impact to your audio experience? Well, interior acoustic treatments and physical setups going to have the loudest say, the final say, I like to say. Hardly anybody's addressing vibration isolation, and that's huge. And we'll talk about it. And the new equipment upgrades and tweaks are having the least amount of impact, but yet that's what most people are doing. So in my mind, if you were to weigh the differences between them, setup, calibration, and acoustics is going to be the most impactful over the electronics. I'm not saying electronics isn't important. I'm just saying, well, to term it one way, if you had a state-of-the-art system and you put it in a poor environment, it will never sound good. If you have mid-fi in a controlled environment, it can sound great, and it'll beat the state-of-the-art equipment in sound quality every time. So let's define who the audiophile is in my mind. It's a person desiring to reproduce the artist's musical work accurately through an audio playback system in a small room. Now, again, we're defining audiophile as playback in a small room, not a large room, not a performance venue. There often is confusion between playback and performance venues. We're talking about playback. So we're talking about control rooms in a studio or playback rooms in our homes. What defines a small room? It is a space that meets the following criteria. Will likely apply sound source frequencies whose wavelengths are longer than the longest dimension of the space. Incorporates shorter decay rates than performance spaces. Has strong early reflections compared to the direct sound. In addition, our typical audiophile room includes the following acoustical characteristics. Decay rates that vary uniquely and wildly by frequency. Again, as I mentioned, our rooms' reverberation times are on a curve. It's not just a number. It's a number at each of the different frequencies, right? And that curve is as unique as our thumbprints or our voices. And so we don't want that. We want a controlled environment so that it is neutral. Each of our rooms has unique room modes too, and this is a matter of construction dimensions and construction materials and methods. And the high ambient noise floor, again, typical noise floor, not quiet enough to give us a better low-level resolution and or dynamic range. And our typical scenario is just dealing with standard electrical service equipment. So ideally, the goal is to neutralize this room. We don't want to add or subtract from the original signal. So one that does not introduce unwanted vibrations. The only vibrations we want are the airborne ones that are coming from the loudspeaker to our ears. I'm going to minimize this so I can see this. So unwanted vibrations are those other than the direct airborne sound. And these may include reflections, appliances, footfalls, electrical noise, plumbing, outside noise, resonances, buzzes, and rattles, vibrations that can cause mechanical and electrical interference. So the goal is a neutral environment. The foundation is our reference for making value judgments. So if it is skewed, so are our judgments. And if it is skewed, so is our experience. So this graph is showing you what the average listening room is versus what the desired is. So let's talk about this. The ambient noise floor. So this is ambient noise floor. When I go and measure a room, I want to know what the ambient noise floor is with all of the equipment, all the audio and or video equipment on, and the HVAC on. And so in our typical environments, we're looking at about 40 decibel sound pressure level, and we would like 18, and that's doable. And you can see there's a big difference there in decibels. And that directly affects the low-level details that we can hear and the dynamic range that's available. So dynamic range, we're looking at typically dealing with about 60 dB, and we should be able to obtain 82 without turning it up louder and maybe causing our ears to bleed. Reverberation times, we're looking at frequencies that vary more than 1 second, frequency to frequency. And instead, what we want is ones that vary less than about 0.4 seconds from 125 hertz up, and with a slightly longer decay below that. And we'll talk about that and the reasoning behind that and how it's to our advantage a little bit later. Room modes, typical to have swings of plus or minus 12 dB. So 25 dB differences. And here we are wanting to know what's the low frequency response of the speaker at 3 hertz. Probably isn't going to matter a whole lot by the time you actually have it set up in your room and listen to it. We can, with proper positioning of the listener and the loudspeakers and interior acoustic treatment, we should be able to get those room modes under control, plus or minus about 5 dB. So great deal of difference. Our typical listening room does not do anything regarding vibration isolation, which is resonances and buzzes and pre and post returns of the original signal, and we'll talk about that coming up too. It's pretty darn easy and inexpensive to mitigate 90% or more of those. So what can we expect under such conditions? With a noise floor, we're going to, and that is not addressed, not under control, we're going to be limiting our dynamic range. We're going to experience poor low-level resolution, and we're going to have distraction. So if we've got noise infiltration from the outside or an appliance or footfalls or whatever, it just pulls you out of your experience, and it's a distraction. And it might be even HVAC that is on, you don't even realize it, and then it turns off and you go, you know, kind of like somebody tapping your shoulder and you're going, what is annoying me? From a reverberation time point of view, and there's an instance of what I'm talking about as far as reverberation curves at different frequencies. So time on the vertical on the Y and frequency on the X. Limited dynamic range, masking of low-level details, poor intelligibility, tonal and spatial interference. As you can see from that chart right there, reverberation curves are tonal. They are absolutely tonal, and they'll mess with timbre, and they'll also interfere with spatial cues. Room modes, nonlinear bass response, and that's usually the first thing that we kind of hone in on. If we, like at trade shows, and we stick our head inside, probably the first thing that we're noticing is how well is that bass sound. So bass is a big important part of the audiophile world, and linear bass response is very important, very tough to desirable and tough to have. Inarticulation and tonal influence, and then mechanical isolation, again, resonances, buzzes and rattles, tracking errors. They didn't even talk about that, about how it can vibrations can interfere with the electronics, tonal and spatial. What's interesting about mechanical isolation is that it affects all the sound quality attributes like no other acoustical treatments do. And it also addresses noise control, which most other acoustical treatments do not. So under such conditions, under uncontrolled environments, can we expect to hear subtle equipment changes? Can we expect to make fair assessments? Might we be compensating for system anomalies? And this is something that I know the audiophile world experiences. Like what Floyd Toole says, the circle of confusion. As we make a change we we buy a new preamp or we buy a new interconnect or something, and it has some sonic changes, some attributes that influence what we hear. But is it right? Is it accurate? Until we know we've got a strong foundation and a neutral foundation, we're just going to be constantly compensating and not knowing really where neutral is or how to get to it. So we're compensating for these room modes, resonances, noise floor, and reverberation. Now this chart is busy, but is kind of fun to look at, in that it's just talking about, we have a very difficult time with terms, and especially at the consumer level when we talk about audio. And it's my hope that over the years, not in my lifetime, that we'll get better at this so that we can communicate with one another and use similar terms that are then understood. And so anyway, you can look at this at some other time, but it's just talking about, as a matter of fact, on my YouTube channel, I have an audio demonstration of this, and I go through the different frequencies, and I plus 12 it, minus 12 it, go to another frequency range, plus 12 and minus 12, and you can see excess and deficiency is at those different frequencies with some music and how they sound. And so anyway, that's interesting stuff. So acoustical objectives, we want to make the room sonically disappear in the playback system. We want to control the influence of structure-borne and airborne sound vibrations. In a small room contained environment, sound waves propagate through the space at the mercy of the size, shape, construction materials and methods, furnishings, etc. And every object in the room is going to have its own characteristics as far as resonating and reflecting and absorbing and transmitting sound, and or re-radiating sound back into the space, into the listening space. Most of the energy is returned back into the listening space. In a typical environment, most of the sound you hear is returned energy. In addition, there's considerable percentage of audible sound sources that are unrelated to the playback recording. Again, like we talked about, the structure playing back later in time, actually before original direct airborne as well, and we'll cover that. So there are newer methods of acoustic measurements. They're constantly, we're even learning new things about how to characterize products in acoustical environments. There's new modeling technologies that are constantly improving. And so there's better means of controlling these sound waves in an organized, controlled fashion. So that's what we're trying to do. We're trying to take chaos and organize it from a sound perspective, so that the results are an elevated and superior audio experience that better represents the artist's intent and gives the manufacturers the best performance that their equipment has to offer. This too is a very busy graph for a presentation, and I don't want you to focus on the top half, but rather the bottom half below the perforated square. So I've got three columns here. One is about acoustic control, the middle one about what the control measures are for it, and the third one is the control benefit of it. So for example, if we look at speaker and listener positions on the left-hand side, what are those control measures? Well, they're where they are located in the room. And then what is the control benefit? Is going to be linear bass response. If we are playing with toe in, then again, we're talking about listener speaker angles, and the control benefit is soundstage and timbre. And first order reflections, reverberation times. Down at the bottom, again, just to emphasize, if we're talking about loudspeaker structural vibrations and the transfer of those resonances, rattles, buzzes, and pre-echoes, We're talking about mechanical isolation, and it hits all of the articulation, soundstage, resolution, dynamics, spatiality, and timbre. Hits all the sound quality attributes. So there's a science behind this. There's an approach to it, and I talk about it like when you go to a doctor with an ailment, and they'll run some tests. They'll do a urinalysis or take your blood or whatever it is, and analyze that, and then give you a prescription to neutralize that complaint. Well, acoustics, when we're talking about noise control or sound quality, in this instance, noise, there's a procedure, there's a process, and it is just the same. We get the data, we analyze it, we then typically computer model it, and what we're trying to do is take the existing conditions, knowing what those characteristics are at many different levels, from noise, frequency, time, energy, and frequency, and then we know what the goal is and what we're trying to mate the two with solutions, with product, with acoustical products. So with noise, the strategy is, one, we evaluate the noise environment under the existing, or if it's not built, under the expected conditions. So we've got to computer model it. We've got to understand the means of each noise path in terms of its octave band sound levels. We've got to measure or model the sound energy levels and spectra and their contributions of each path. We've got to measure or model the total noise octave band spectrum at the receiver location. Step 2 is determine what the acceptable noise levels or criterion are at the receiver location. Step 3, obtain the difference between the noise energy in step 1 and C in step 2. 4, prioritize each noise path contribution in regards to the goal. 5, establish the physical, budgetary, decor, local code, or other constraints that might interfere with or limit our solution possibilities. And then 5, evaluate the various design and material solutions to meet the objective goals to the best of the ability. So just want to point out that there's an approach, there's a scientific approach to it. We don't just guess. I constantly hear about, well, I just called up so-and-so who makes this product, and they said, give me the dimensions of your room and we'll tell you what to get. Can't do that. That doesn't give you anywhere near the information you need. And typically what they then do is sell you too much product, more than you need. And you're typically only addressing 500 hertz and up and not addressing the lower frequencies, and on and on. So this is just an idea of all the different types of noise paths there are, and ways that it can be addressed. So for example, you look at these here, if we've got a noisy appliance, we can line it with a partial enclosure, or we could buy a quieter appliance, or we can add some sound absorption in the room itself where it is reflected. We could line a barrier. We can actually put an acoustic barrier or block. We can add vibration isolators. We can put a break in the structure in the floor, for example, or even add white noise or earplugs. So with noise, there's many paths and there's many solutions that have to be investigated. So back to our typical environment. In this chart, I'm showing, just for ease, I'm showing triple F in an orchestra as being about 100 dB. And so the blue is the area of dynamic range that we are in the typical residence at 40 dB, typical quiet residence, we're missing out on. And for reference there, I've got, normal conversation at about 60 dB and our quiet residence at 40. And we should easily, well, I don't want to say easily, but certainly doable without too much expense, typically achieve an ambient noise floor of about 18 dB. I say typical, and you guys are from San Francisco. So in the city, maybe not. But in suburb areas, we can typically do that, especially if we're talking new construction. From an HVAC point of view, this is what we want to look at. So, for example, this is an actual measurement, and with the before and after, changing the HVAC. And so we went from what a 25 down to a 20. And you can see at the low frequencies that rumbling, which is what this would have sounded like, is no longer audible, where before it was very audible. This is interesting in that we talked about reverberation curves. And here's an example of, I took, this was a little while back, but I took 50 measurements that I had done at clients' rooms and just averaged them. And this is what I ended up with. So out of 50 audio rooms, look at how many of them have, low frequency lingering at over 1.5 seconds. And how non-linear this is. So you can imagine how, again, tonal this is. Now, we do get very easily acclimated to the reverberation times in our rooms and then tend to ignore them. But when they're under control, the difference is tremendous, and we're going to talk about that. So, for example, in a gym, let's say, where you've experienced it, you can imagine what it's like in a gym, and I were to say the word, and you couldn't read my lips, and I were to say the word bath, bad, band, bat, you'll have a hard time unless you hear the rest of the sentence and put it in context. That consonant is going to be completely covered up, and you won't hear it. You'll hear bath, but you won't hear the ending of that word because it's masked. It's covered up by the lingering reverberation that's bouncing around in the room. Now, over on the right-hand side, if we control the reverberation times by adding the appropriate amount of absorption material in the room, it's now revealed, and you can hear the word clearly. So it's not only articulate, speech intelligibility, but it is also more dynamic. As the room is live and reverberant, it just is a cacophony of sound building up on itself and tripping over itself. And in a controlled environment, the sound starts and stops as it should. This is an example. Again, these are real measurements. So this is a room. This was a carpeted media room. And so the reverberation times here are taken. Typically I'll take 7 measurements at each position. This is 9 positions. And so on the top graph there, you can see, okay, we need to get some control under the reverberation times and see how they vary from seat location to seat location. This was in a home theater room. And then we make a product called the frequency response panel system it's a number of different panels that address different frequencies. And so you model the room after doing tests like that above and determine what panels need to go where and what quantities. And so you can see the result of our FRP system, and we can do this all day long. In fact, we do. We've got I don't know how many across the world where the reverberation times are all in each of these different rooms, just like what you see on the bottom graph. They're controlled, they're neutral, and the result is great dynamic range, great articulation, no problems with timbre or spatial cues, or they're huge and accurate and solid and all. Where until you get there, none of that can occur. In fact, most people are dealing with 1 or 2 inch fiberglass panels. And again, like I say, they'll typically end up overdoing it. And so they go from a room that was too live to too dead, but only in the mids to high frequencies, and not addressing at all the low frequencies. And in fact, even the mid range with a 1 or 2 inch panel, which is in the red curve that you see here, the yellow being the room untreated. The red, this is a room that I worked on and wanted to make it the best I could with 1 inch panels. And so you can see the best I could only begins at 500 hertz. I can't do anything with those below 500 hertz. And that I still am choking the room at the higher frequencies. There's no way I can get it right. So there's a small little, around 1200 to 2K where it's right where I want it. And it's not anywhere where I want it above or below. With our frequency response panel system, I can get it where I need to, because I have the control over that with the different panels. So anyway, and this also is with our panel system. But what this test is they call it the MAT test, or music articulation test tone, and it's a sweep, but it's a gated 1/16th of a second on and 1/16th of a second off, and that sweep sounds like do 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 do, and then it goes back down again. So this is a before and after. This is all about low frequency articulation and the room ringing, playing back, after the speaker, the signal from the speaker has stopped. And you can see in the red line, it's very unarticulate, and it even sounds like this. It'll sound like do 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 do, instead of starting and stopping, as you can see in the blue line. And this is about mechanical isolation, and we make a product called the equipment vibration protectors, and so this is just showing this is the lab results this is just an impulse hammer. It's a particular standard test using an impulse hammer with an accelerometer and whatever the device is under test between the two. So nothing else is no other variables in the system. And so on the top left is no isolation. On the top right is with our EVPs. And then down below is an aluminum cone. So in other words, not an isolator, not a mechanical isolator, but rather a coupler. And so if I change the shape of that aluminum, or I change the size, or I change the loading, or I change the aluminum, or I make it a different, rigid material, that curve there is going to be unique, and it will be different every time. And it'll interfere with whatever the material is that I place it on, the resting platform, and the load, and all those things. So in other words, the sonic signature that you see there will be different, unpredictable, undesirable every time. And you can see there are peaks there. There are amplitudes there. Those are resonances in the audible range. So without this, the spike or aluminum cone or whatever the material is, it's a little quieter. When I introduce them to the component, I hear it, and it's a little louder. And I think audiophiles are often fooled by that if it's a little louder. So on the upper right-hand side, that's the EVP. As long as it's loaded properly, that is the curve that you get every time, regardless of what the resting platform is or whatever. You're going to get that every time. Okay, so playback. I said that we were going to talk about arrival times. There's one arrival time that we want, and that's all. And we're actually experiencing 4. And so the first arrival time, understand that in material, sound energy travels faster and farther in denser materials, denser than air, which is the one that we're interested in. So the first arrival, when we play something on our system and our speakers are coupled to the floor, the first arrival is structure borne, and it comes to our seat, goes to our butt, and via bone conduction goes to our ear. It's fast, and it's before the direct signal from the loudspeakers through the air to our ears. That is the second arrival time, and that is the only one that we want. The third arrival time are going to be reflections off of the wall, adding to echoes or flutter echo or reverberation and so forth. And then the fourth is going to be structural resonances, buzzes and rattles too, but structural resonances, meaning where you've got, any material has resonances, but especially those with cavities, like for example, our floors, our walls, and our ceilings are notorious for playing back. Like if you do a light fist bump in between studs in a typical residence, you're going to hear about 70 hertz. Well, that anytime you play back 70 hertz on your system, it's going to resonate in sympathy, and it's going to act like a capacitor. It's going to take that energy and it's going to hold it for a moment, and then it's going to release it and play it back into the space later in time after the original event has stopped. So when you decouple, when you mechanically isolate the loudspeakers from the shell, because everything's hard fastened, everything's interconnected in typical construction, that quiets down when you decouple, and it's an amazing experience. It's really quiet now and so much more articulate. So here's kind of a cartoon example of what I'm talking about. With a subwoofer on the left-hand side, you all have experienced, you play a subwoofer and you can hear that subwoofer anywhere in the house, right? Because once those vibrations get into the structure and it is hard fastened to everything, it's not coming out, and it easily transfers to the other end of the structure, and so you can hear that subwoofer. So this is structure borne, not talking about the airborne, just talking about the structure exciting. If I decouple the subwoofer, now the structure is quiet and it's not going to be playing back later in time, and I'll only hear the airborne. So acoustical upgrades, what that means is we're talking about speaker listener locations, getting the bass optimized, and then the soundstage and the timbre. Well, that's a free one, and most of you guys are dealing with that and understand that. Isolating speakers, this is so important, and it's so easy and so inexpensive to do. So this is like the equipment vibration protectors. It's gonna hit all the sound quality attributes as well as noise control, and get rid of buzzes and rattles. There's an audio, actually is a reviewer. He had so he reviews with equipment vibration protectors, and he moved to a new location. First thing you do when you move, right, and you're into audio, I know because I've done it a couple of times, is you set up your stereo system because you're real curious as to how it's going to sound crossing your fingers. He set up a stereo system and found that his fireplace rattled at a particular frequency, and he's going, oh, and it's it's inside of a massive fireplace. So he's thinking, oh my gosh, what am I going to do? This is going to be really expensive to mitigate. And then he goes, EVPs. And so he simply put EVPs under the speakers, and the problem was solved. So super easy, super inexpensive results. Acoustic treatment. So inexpensive to expensive. You're going to want to control the first order reflection points and then look at where the reverberation times are in the room after. And then structural treatments. This is, expensive, especially if you're talking about, a remodel. But that's where you're going to be able to address room modes and sound transmission. So now let's talk about electrical. This isn't quite, won't go into it quite as deep, so it's a little quicker. Average listening room, we're looking at a ground resistance of 25 ohms or more. You know, rarely do I see anything that good. Usually when I go to a residence, I'm finding that it's higher than that. Now, those of you who are in apartments or so forth are probably pretty good. But when I'm talking about a separate, you know, residence, without, you know, grounding the cold pipe, you're probably looking, I mean, I really don't ever see 25 ohms or less until we address it. Now, NEC, it's a requirement. You're not supposed to have the house signed off unless you've got 25 ohms or less, and yet I don't run into it. Desired, we want to get 4 ohms or less, and this is pretty doable. Peak current capabilities, talking peak current capabilities, okay? Less than 500 amps, we'd like to see more than 1,000 amps. Voltage distortion, we typically see more than 10%, we want to see less than 5. Common mode rejection, we typically see more than 2 volts, and we want to see less than 10 millivolts. Normal mode noise, more than 4 volts, we want to see less than 50 millivolts. Harmonic content, many, goes all over the place. We want to see less than 3% at the third and nothing above. And then electrical isolation, typically nobody's doing anything about it, and you want to do all that you can. So electrical buzz issues, they can vary from inducing audible hiss to buzz to hum and other interferences. But what I find, and also, of course, it could cause equipment damage and errors and so forth. But audibly, what's less obvious is with poor quality AC is it sounds flat. The sound stage is flat and it sounds thin, and it sounds edgy and fatiguing and harsh. And again, you could be fighting that and not realizing that, you know, thinking that it's your speakers or thinking that it's a cable or whatever, and you're never going to be able to get over it to rectify it until you actually address the real issue, the real problem. And so, you know, I'm sure that many of us have gone through this before and just, you know, didn't realize that it's poor AC quality. So again, can we expect to hear subtle equipment changes? Probably not. Can we expect to make fair assessments? No. Might we be compensating for system anomalies? Yes. Minimize potential. What are the objectives? We want to minimize the potential to ground, maximize the current delivery, minimize the power factor error and K factor corrections, minimize line coupled EMI and RFI noise, minimize field coupled EMR and RFI noise, isolate critical components from the main service and from each other, and provide optimum safety for personnel and equipment. With again, technology, newer test and measurement equipment reveal these problems, and there are new methods of grounding and bonding and shielding and especially with as technology improves or grows or continues, I'm not sure what the word is I'm looking for, you know, it's more sensitive equipment. And so the trend for lower voltage circuitry with higher density integrated circuits, more RAM, and increasing clock speeds is just going to continue. So the equipment is becoming more and more sensitive. We're adding more and more of it to our system and increasing the noise and the potential for problems. So yes, as I explained, there's new methods of grounding and filtration and isolation and bonding and all that to improve the performance and reliability and longevity. So yes, the end result will be greater dynamics, speed, resolution, and imaging in both the audio and the video presentation. So here's some general electrical recommendations. Oversize everything and don't condition unless it's required. And what I mean by that is is there's a lot of power conditioners out there, and I don't use them unless I know there's a specific need. Just like anything else, like an acoustic treatment, you don't just put up acoustic panels and think you got it. Maybe you got the wrong ones, or you got them in the wrong place, or whatever. You need to test, you need to investigate, you need to find out, what is the problem? Is there a problem? If there is, at what level, at where, and then how do I address it? But some good general rules are to overrate everything electrical. Clean any visible corrosion and carbon deposits seen on the grounding rod junction, bus bars, breakers. Replace old circuits or that have been tripped several times, and outlets as well. Gas tighten or exothermically weld all connections to the ground and rod junction, bus bars, breakers, and outlets. Try to avoid other AC and signal cables by 5 feet, or cross at right angles, and isolate when required. Again, these are just kind of good practice when possible. So in summary, good signal integrity means flowing unimpeded through the chain. And those 3 ingredients are quality materials, large, smooth, clean, dry contact surface areas, and tight connections. So here is an example. We were talking about residents having a ground impedance of 25 ohms or less to meet NEC requirements. Now, what I'm measuring is the ground electrode conductor at the service entrance, and you can see this is a before and after. So I measured 100. This guy had probably easily $1 million stereo system, and he had 142 ohms at his service entrance, and with, I don't know, maybe about $1,000 or maybe a little more, we got it down to less than a half an ohm, or about half an ohm. And he was very appreciative. We did this in stages. So the first thing we did was improve the grounding, and then we improved the electrical circuitry, and then we introduced an isolation transformer. So we did it in stages, and each time taking measurements and objectively and subjectively evaluating. So here's an example of voltage harmonics before and after. You can see 11.6 THD. You can see harmonics going out to the 15th. And then afterwards, THD is 3.4, and you don't see anything above the 3rd harmonic. This is common mode noise before and after. And this is, I guess I didn't do the other. Electrical upgrades, ground resistance, often less than $1,000. Lower impedance means less reflected noise in the system and better protection. Cabling, moderate to expensive. Quality wires, configurations, and connections mean less interference, less resistivity, and better impedance matching. And then an isolation transformer, looking at 10 to 20K. A separate, a separately derived system means a dedicated clean power, no longer subject to the grid. So this isolation transformer, I don't look at it at all as being a power conditioner. It's not. It doesn't have any filtration in it per se. It's giving you clean power, and it's offering it. It's offering isolation from the grid, from the rest of the not only your house but the whole block. So from the isolation transformer, you would have dedicated circuits for the stereo system. So back to the plot, we were talking about prioritizing. So here's a playback priority pyramid. So you prepare the ground, you've got your foundation, and then you can start looking at tweaking it. So you've got to deal with the coarse adjustments before you can deal with the fine adjustments. So there's 5 takeaways from this presentation. There are fundamental sound quality attributes which are known and measurable. The typical listening room is pretty far from the ideal, which lowers the performance of the equipment and the experience for the listener. There's a hierarchy to achieving sound quality. Coarse changes are required before fine-tuning can be perceived. Only a neutral environment can offer a fair and optimal playing field. And 5, the biggest obstacles are often the smallest costs. Thank you. Open it up for any questions.
Thanks, Norm. So far, don't see any questions. But,
wow, that's a first.
In the chat box yet. I bet they'll come up. But, one thing that came to mind is everybody's room is different, different sizes, different shapes. Well, some may have an open to another room. Others are, you can close the door. So there's a lot of challenges there, I would guess.
Right. Yeah. One of the things that that I'm particularly annoyed with is a reverberant adjacent space that really distracts me. To hear a space after the event again. So anyway, but that's usually fairly easy to address and not very expensive. And some people are less sensitive to it than others. Well, gosh, I'm usually this question and answer period goes on for a couple of hours or more. So I'm really surprised. I mean, I've never had this happen.
Mr. Varney, Mark's in the Saros here again.
Okay.
And I do have a question. I was trying to get it in, but I had muted myself. I have exactly that issue, which Larry just referenced. In my listening room, one wall, the speakers are shooting across the room. One wall is all glass, it's all windows. And then the other wall is only a half wall, and it's open to a foyer and a hallway which goes 90 degrees or perpendicular to the direction of the speakers playing. And so when it comes to first reflections, I have a really awkward situation because the right side is rather highly reflective, except I have cellular blinds, and then I have pool drapes or pool shades because I use it for my theater room as well. And so I actually have 3 different surfaces, right? I have the glass, I have the sheetrock and cellular blinds, or then I have the accordion shades.
Right.
So that's kind of complex. And then on the other side, it's only a half wall, and it's the far half from the speakers. So if I do the mirror test, where I'm identifying where the first reflection point is, well, the first reflection point is going down the hall.
Right. So you have non-symmetry as far as your horizontal,
yes,
stage. Well, so there's a couple things that come to mind. I mean, just to take care of that situation, it sounds like it would be fairly easy to make an absorber that is on a stand that's mobile, that could be introduced when you're seriously listening, to get that first order reflection and get it symmetrical right and left.
I see. Okay, that's what you'd recommend, is a panel on a stand.
Yeah. As a matter of fact, we're going to be introducing our Polyflex diffuser on such a device. But
Ah,
the same kind of a thing could be done with an absorber as well.
okay.
Yeah, yeah. And then it sounds like you've addressed the windows. You've got curtains and so forth.
Yeah.
But I mean, until you do like what we've discussed, until we actually do an analysis, run some tests of the room, we don't know really where the reverberation times are. We do know, obviously, that we've got some non-symmetry as far as first order reflections.
Yeah.
But it'd be nice to know what the reverberation times are, to know, like for example, if you're not that I know anything about your room, but let's say that it was very absorbent already. Well, then we don't want to introduce more absorption. You want to introduce a diffuser at that first order reflection point.
Right. That makes sense.
Yeah.
Right. We don't want to take too much energy out of the room.
Never. There's this small little window that we want to be in. We don't want to have too much absorption, and we don't want to have too little. Yeah. Now that's like I say, that's very easy. That small window, very easy to over absorb, and I run into that all the time. On diffusion, on the other hand, once the reverberation times are under control, it's very hard to have too much diffusion then be introduced into the room.
I see.
Yeah.
And so,
So we have a,
go ahead.
okay, yeah, we got a question in the chat. Curious about isolation transformer. Doesn't noise on the grid couple into the secondary of the isolation transformer? I understand isolation transformers are good for compensating poor grounds.
Oh, I'm not thinking that they're good for isolating grounds, but they are good for isolating from whatever is before them, and that's their whole function. That's their whole purpose is to is to isolate, right? So by introducing an isolation transformer, we're talking a big isolation transformer right at the service entrance, and hopefully very close to the sound system as well. And the isolation transformers that I like to use are balanced. So Equitech or Taurus, they make balanced isolation transformers, and these are great in that common mode rejection is essentially taken care of, and power factor correction is essentially taken care of as well. And they're pretty affordable, and they are designed for audio equipment. So it's not just an industrial isolation transformer. This is designed for audio equipment.
Yeah. So I had a couple questions. One, would you be able to provide the PowerPoint to us so we can, when we post the video, that we can link that as well?
Absolutely, sure.
Great. And
Yeah,
then
some of those charts are complex.
yeah. And I've been curious about how best to measure power quality and stuff. And I saw you had a fluke meter for using on that. What model is that? Do you know?
That's a 43B.
Okay, great.
It's a nice piece, and there's a lot you can measure with that piece, but then there's a lot of things you can't measure with that, and so there's I've got a case that's like yay big that if I'm going to be measuring power quality, there's primarily 3 devices like that I'm going to be using. No, 4. There's 4. So yeah, anyway.
All right. Let's see. So we got another question. In a combined digital and analog system, will separating the circuits supporting the respective equipment help reduce the various noise products? Also, can you discuss the difference between your EMIs and the typical dryer pads available at hardware stores.
The typical what at hardware stores?
It's a difference between your, EMTs, I guess, and the typical dryer pads available at hardware stores.
Anybody, can anybody explain to me what that is? I don't know.
Yeah, I can notice.
Okay.
I've got some pads that I didn't know about your products, but I bought some pads. They're squares. They're about 3.5 inches, and they're rubber on top and bottom, with cork inside.
Now I know what you're talking about. Okay.
I stuck them under my subwoofer, and it helps.
Yeah. Okay.
You
I thought we were talking electrical, and now I know what you're talking about. You're talking about isolators that you buy at the hardware store for like under appliances.
Yeah.
Okay. So if you look at those, or if you go to Amazon or something, you'll find those. And I get confronted with this all the time, so much so that I have them with me at the trade show to demonstrate what they are. But understand that they're really some of the ones for dryers, which are not heavy pieces of equipment, they can definitely help. They're typically sorbethane, but the other ones that are that you would buy are a dense foam and a dense cork.
Mm-hmm.
And if you look at the specifications, they're designed for 50 pounds per square inch. Okay, that's a heavy piece of equipment, not like any of our audiophile stuff. And it does not do a good job of coupling. I use a little music box mechanism at the trade shows, and I demonstrate it. So I just compare it using one of our EVPs, and transmit the vibrations. This is it on my desk. And it's about a 27 dB increase over just in air. I'll do the demo. So those tines are moving plus or minus 0.1 millimeter. And in the air, the impedance mismatch is such that it's really hard to hear. Okay. But as soon as I couple it to my desktop, that's a 27 dB increase. Now my desktop, it's amplifying at 27 dB, and the desktop is only moving a few billionths of a meter. Okay. And if I put it on my EVP, it's as quiet as it is in the air. I know you can't see it, but anyway, that's it on the EVP.
So for those folks who don't know what we're talking about, I talked to you at the show up at Seattle. The EVP has some aluminum plates and a different filling, basically. Is that right?
Yeah. So it's a fiberglass core, and there's different densities. Standard, we make 3 densities and 2 sizes to handle different loads, and we can customize it too. We can make like fairly common, we'll make 3 4-inch EVPs to sit under a full 900-pound grand piano. So we can make them as dense as we want. It's just always, with isolation, it's always a matter of the load. That's one, for one, if it's rigid, it's not going to isolate. And if there's no one size fits all with isolators. So if you're looking at a particular product and it's one size fits all, that should raise a big flag. If there's no specifications, no test reports either as far as their performance, that too should raise a big flag. Everything that all of our acoustical products are tested with standard tests and accredited labs, and we publish the results online. So it's not just verbal claims.
Okay.
Can I say something about your EVPs?
Sure.
You can.
Okay. So I do home visits anywhere from two clients to 7 clients per month, and I always bring the EVPs with me, and I do it at the very end. After this one's, I'm bringing this to China with me to go to my Chinese client. and I need 4 more, by the way. I'll be making that order from you. It is amazing what these things do. And I always do it at the end after we've improved everything we can improve. And I say, okay, now watch this. And I put them underneath all the transducers, right? So underneath certainly all the subwoofers, certainly underneath the main speakers, but I'll just start with just the subwoofers. And you would think, like I did, the very first time we experimented with these under asymmetric distributed bass array that I put in at the Capitol Audio Fest. And those subwoofers, of course, it was on floated concrete. We're in a hotel.
Yeah.
I figured, how much of these are really going to work? Because how much can you excite a room that's built out of concrete from 4 subwoofers that are each doing a quarter of the work of one subwoofer? So they're really not, compared to a single subwoofer, they're not doing all that much work. So I figured, I was concerned this might not work. Everybody in the room within a few bars of music said, whoa, don't take those out. I've since tried it on concrete on grade. So this is concrete slab on earth. Amazing. Every time. It doesn't matter how sturdy the structure is. These things, when you decouple, and people think, well, I've already decoupled. I'm using cones, or I'm using what are the really expensive the resonator things. Anyway, you name the price. Right? If they're rigid, they're coupling. They're changing the mechanical impedance relationship between the structure and whatever is sitting on top of them. That's for sure. Oh, steel points that I was thinking. Yeah. They are changing the mechanical impedance relationship, but they are not decoupling. Right? And so it's amazing how much more there is to hear when you're no longer hearing the structure play its part in the musical performance.
Yeah. Yeah. And that's what I was saying, is that, hardly anybody has ever experienced that. I mean, hardly anybody.
Yeah.
Unless you've done this,
you
haven't experienced it.
Yeah.
And it affects all the sound quality attributes.
Yeah.
So really appreciate that, guys. Relative to the question on the digital and analog, what I meant was running a pair of circuits to the stereo, putting all the digital on one and all the analog on another.
Okay, so yeah, that's a good starting point. Back in the 95, and this was pretty innovative back then. Skywalker Sound, I did the electrical renovation, I guess you'd say, for them. Now at Skywalker, they had their own power plant.
Wow.
And yet they've got, multiple suites, multiple studios. And so this was for the scoring stage, the big one. And so what I did is introduced a balanced power isolation transformer, ground reference grid. Now those 2 items, that was an expense. That was it was, over $1 million. But we also, I isolated all the digital from all the analog and all the recording from all the playback equipment. And so whenever you can isolate, it's going to help. And yes, I would definitely recommend having digital isolated from analog for sure. And if you can even isolate beyond that, that's going to be of help. Everybody's situation is different. Every piece of equipment is going to put different amounts of and different types of noise onto the line. And so your results are going to vary, but these are good practices for sure.
Thanks.
We had another question about isolation transformers with somebody that's in a condo and dedicated circuit. Would an isolation transformer help on my dedicated line? Where would I place it?
Right. Okay. So yes, you can get devices that are made for that, in a box. So it's not a giant, 400-pound giant thing that's got to be down at the service panel. This can be in your condo or an apartment, and you're going to have it plugged into the circuit, and obviously it's not. Of course, he said it was dedicated, but typically That wouldn't not be the case. But now you've got an isolation transformer, and so now you do have dedicated circuits, and so you're going to plug your equipment into the back of it. It's designed to do just that. So both Taurus and Equitech make such devices.
Yeah.
Okay.
Good. Yeah, and I use a trip light isolation transformer. That's a hospital grade that works quite well too. So
Right.
anyway, a couple more questions. Do your EVPs affect electrical components, which as DACs or preamps, amps, etc.?
Yes. So we talked about prioritizing applications, and with the equipment vibration protectors, I recommend starting at the source of vibrations first. If you've got subwoofers, they're the most energetic. So I would start there, and then your mains, and then you start addressing your sensitive electronics. And what that would be any tube electronics, anything with a quartz crystal in it. So any digital device is going to be sensitive to vibrations. Tubes I mentioned because they're microphonic. Turntables, right? They're very sensitive to vibrations. And then, work your way down from the source down after you've dealt with the sensitive electronics.
Very good. Next question. Where are you located? How do we contact you about engaging you to perform your magic locally?
Okay, yeah, I can travel anywhere in the world. I'm in Ohio, just kind of east of Columbus, so right in the center of the state. And you can just go to AV Room Service or Facebook to AV Room Service or my name, and you can reach out to me, private message or whatever. And then if we were to engage, I'd give you my personal email address so that we can transfer documents or whatever is needed.
Let's see. I have Vandersteen 3A signature speakers with 3-point stand. The front 2 feet carry more weight than the third foot.
Not a problem. You can mix EVPs. So yeah, again, it's always a matter of of loading them properly. On the website at our on the page, there's a calculator. So you put in the weight of the component, and it'll tell you what the options are as far as solutions. But I realize what the question is that the Vandersteen is heavier in the front than in the back, and the Vandersteens are time aligned speakers, and so you want to make sure that the speaker cabinet is plumb and level.
Sure.
And with the first order of EVPs, we include bullseye level with it.
Yeah.
And
Your average shower,
you can, somebody needs to mute. All right.
Yeah.
So you want to make sure that speaker cabinet is plumb and level. And with the EVPs, you can use shims, and you can use any material that you want. So typically you're going to shim underneath it between the floor. You could use any material because any vibrations that then get to the core that's where the work is done, are going to be mitigated. And again, conservatively, 95% of the vibrations from 5 hertz on up are going to be controlled. So any material can be used as a shim. I hope that answers your question.
Very good.
Larry, can you send out the website where we can look at the EVPs?
Oh, at
Sure.
avroomservice.com.
avroomservice.com.
avroomservice.com. AV like audio video, roomservice.com.
Thanks.
So, Norm, this is Antonor. So on the EVPs, what's the dependency on frequency on the absorption or compliance, in
Okay.
terms of noise, structural noise insulation, for example?
Right. So
Does it work across a range of frequencies, or
yeah,
which are those frequencies essentially?
it does. Yes. So when you load this properly, and again, we make different sizes and different densities to handle different weights. When you load it properly, the natural resonant frequency of the device is about 3.4 hertz. It's between 3 and 4 hertz. And you can see on the testing that was done that right at 5 hertz, they are effective right at 5 hertz on up. In the test report, the resolution, we took it to 500 hertz, just so that you could see there's a trend. It's continuing to get better and better. And it's 500 hertz and below that where we're really trying to do the work. And to take it beyond, then you'd have to smooth out that curve. And I really wanted to show how they are effective right at 5 hertz and up. So yes, I think that answers your question.
Yeah, thank you. Another question that I have is about the use of spikes and cones, right? I mean, because those are coupling devices, not uncoupling.
Yeah.
devices. So, and those are used in many things, right?
Oh my gosh. Well,
so-
okay. Yeah, they are. And that's a question that I get all the time is, well, if these spikes or these coupling devices, these hard rigid feet are, why are the speaker manufacturers using them? Well, all I can think of is that because the market says that they are cool, and they look cool, and they definitely sound different. But let me just say that there is confusion, and for example, there is also interference. I'll bet that these guys, when they're doing their anechoic measurements, are not using the feet. And so when I've got a hard, rigid coupler like this, a cone or a spike or something like that, vibration is always a two-way street. It goes both directions, right? And so if I've got this on a resting platform, the cabinet is vibrating the foot in a certain way, which is being transferred to the resting platform, whatever that may be. And it also reflects back through this foot and into the cabinet again. So the feet not only excite the structure, but they excite the cabinet. They'll also dampen the cabinet in a way too, but so will the decoupling. So the cabinet also is going to resonate and vibrate. Whether you are coupling or decoupling, that cabinet will still move. This doesn't have any effect on that. But I feel that back when these were introduced back in the 80s or so, that people heard a difference. I know they did. I can. And every time I use something different, I hear a difference, right? And we know, showing the test results, that every time I make a change to a coupling device, the signature, the amplitudes and attenuations change. And we don't want any of that. We always want to have attenuation so that there are no peaks and that it is neutral and repeatable and consistent. That is the goal. That's what we're always after. So why these are used on speakers is just lack of understanding, because they're never going to be the right solution. Every time I use this, if I put it on a different resting platform, it's going to perform differently. It's never repeatable, never consistent, and never neutral. And if I just may say also that you do not find this confusion in the pro audio world, and it has never existed in the noise and vibration industry. This confusion is only found in in the audiophile world.
It's amazing how much ignorance there is among many equipment designers of just basic physics that they should simply know better.
Yeah,
Force
yeah,
equals
but
mass times acceleration. You got a rigid coupling, it's not a mechanical diode. Although I've seen that claim
Yeah,
many times and
yeah,
still
so
do for manufacturers who should know better.
exactly.
Ridiculous.
Exactly. There's so many myths out there. But I think that, the market also dictates to the manufacturers that, hey, we want those, not knowing the customer, the end user doesn't realize, no, you don't. You do
Yeah.
not want those,
Yeah.
but they look cool or whatever. And so the manufacturer is complying. So, yeah.
Good. We have a couple more questions. In the electrical portion of your talk, you spoke of two different types of phenomena, field and what was the other one?
Line.
Okay, can
Yeah.
you
So
speak more
EMI and
about that?
RFI line and EMI and RFI field. Yeah. Yeah.
So can you talk a little bit more about that, the
Those
sources?
electromagnetic interferences and radio frequency interferences being introduced either on the line or radiated in the air into the equipment. That's the difference between line and field coupling.
Yeah, line, I've noticed if you have a dimmer switch on your lights
Yeah.
in your room, they can wreak havoc. Those are
Yes.
lines, right?
That's correct. Yeah. So, or fluorescent lights, so if you've got a dimmer, there are some dimmers that cross over at zero potential and that can alleviate that problem. More expensive types of dimmers, but anyway, that's most likely the solution for that problem.
Another question. You're obviously very knowledgeable. What is your engineering background? Mechanical, electrical, or both?
Not really. So I've been into this for a long time. My dad was an electrical engineer, and he was you can read about him and my grandfather. My grandfather was a pretty darn big inventor at the time, so I was heavily influenced and learned a lot from them. But academically, really, no. As far as acoustics, especially, there was nothing. There was no schooling as far as acoustics. There is now, but that's recent. That's not in my generation, or even generation ago. But there is now, and boy, do I wish I had now. So everything is my background is working at the Science and Technology Center at Owens Corning. They have one of the best acoustic labs in the world, and that's 10 minutes from my home. Anyway, so mine is firsthand experience and reading and studying and all that, but no, I don't have a PhD in anything.
Yeah, but you're selling yourself short, man. With
I'm
your
not,
experience with AWSS and
yeah. I get in with people who are smarter than me and learn from them. That's where I've learned the most is, working with individuals or being members of different organizations where they're way brighter than I am.
Another question, could there be a benefit to using the cones to couple to the EVP to get as much energy out of the speaker cabinet as possible?
No, no advantage, no super disadvantage other than one. There's two things actually that I would like to mention. If you're talking about a loudspeaker, you might be, depending on the loudspeaker and also depending on the distance you are from that loudspeaker, elevation might be important, right? It's going to sound a little different, and so who knows, it might even sound better being elevated as such. But the primary issue with that is if you've got a device, a piece of equipment that has removable spikes or rigid feet, then do so, because of like what we talked about before. If the cabinet introduces vibration into the cone or the foot, it can reflect too. So even if I've got an EVP under it, there's going to be some interaction between the cabinet and the feet. And if I remove that, now there's not. And so if you're looking for neutral, I would recommend removing such feet if you can. But from a transfer point of view, does not matter. From a transfer into the structure point of view, you can use the spike or not. It does not matter. And this won't drain anymore. As a matter of fact, I guess you could say it drains less because it can reflect energy back into the cabinet than if you went with this alone.
Good. Another question, what sort of other industries do you work in?
I'm not sure. I mean, noise and vibration, recording, pro audio. I'm a musician myself. And homes, cinemas, that kind of thing. I do a bit as far as performance, but mainly just smaller performance venues, not large venues. So my specialty is in small room acoustics. It is not in large venue or performance type venues. But small room acoustics typically applies to recording studios and audiophile, critical listening and viewing environments. That's the way I define it. And that's usually a small room.
Very good. This is kind of more of a comment, I guess. An easy way to evaluate the reverb is to use REW, the free software with a calibrated microphone.
Mm-hmm.
You have any thoughts on that?
Yeah, sure. REW has come a long way. As a matter of fact, just this last month or so, I decided it has come along a far enough way that it's pretty darn good, it looks to me. And the other reason why I decided that I better get involved in it is that so many audiophiles have it because it is free. And so I have downloaded it. I have not messed with it much. All my software and microphones and stuff are what they call class 1 or class 0. So in other words, expensive, high quality stuff. But I see so much potential in getting familiar with REW that I have downloaded it, but I haven't had the opportunity to mess with it yet. I bought one of the microphones. I haven't even opened it up. But I plan to. There is the reason being is that I could have, I know that they do impulse response. There's a company called Studio 6 Digital that I've used recently that now allows a customer to take a recording for me and send me the WAV file, and then I can dissect that signal in any domain I want. I can compare it energy versus frequency or time versus energy or frequency or anything, and learn even noise floor. I can learn the characteristics of the room. Unlike, the expense of me traveling with my equipment and spending, a couple or 3 days away from the office, I can get probably 75% of the information that I need this way, and it's very affordable and easy to do. And I can get that information from anywhere, anybody in the world. So the problem with Studio 6 Digital is really only that if you're not an or Mac or iPad user, it doesn't work. And I think the software is like $50 or something like that. So with REW, so many people already have it, and so I just need to play with it. and see if I can utilize it the same way, offering such a service where the customer, I can tell them, I can give them a sheet and say, this is how I need you to make this impulse response recording, and this is how you send it to me. And for as a service, I can then make recommendations because I can see how his room, how the sound is propagating in his room. I can get reverberation times, I can get articulation, I can get signal to noise, I can get a lot of information. And then make recommendations as to, you know, solutions. This is what you need as far as acoustic panels. This is the quantity you need of these panels, and this is the location you need to place them. So yeah.
Good. All right, Mark wants to engage you. So Mark
Hey.
will have to reach out to you.
Sounds good.
So Norm, I remember a conversation I had years ago with Jason Serenos and Bob Walters on the BAS, you know, the Bay Area Audiophile Society, regarding room acoustics. And many of our houses have fireplaces, right? So I was wondering if there is any impact. What's the impact of having a fireplace with the flue? Is that some kind of a resonance? You know, that comes back into the room, or it's tunes the room in a particular way?
Yeah.
Do we need to block it? You know, how do we deal with fireplaces?
Yeah. Yeah, it definitely is. So typically, I mean, they do vary, and some are just impossible to what's the word, address adequately and affordably and so forth. But typically you can close the flue, you know, if there's no fire, and kind of seal off that return. Because yes, it definitely, some are much worse than others. Some even, like I talked about earlier, buzz and resonate and or return reverberation times, reverberation back. And then another thing that you can do is with an absorber, you can block the front of the place. So you've got two means of blocking and of absorbing the sound that is returning from the fireplace, and usually that's sufficient.
Yeah, because we're doing some listening evaluation at Jason's home when he lived in Oakland, and I saw that fireplace and it was completely open, and you were listening to a very nice system, right? Wilson audio, you know, and everything else, but you know, it wasn't clear, you know,
Right.
how that would impact, you know, the sound.
Right. Yeah. Yeah. So closing the flue and then an absorptive panel in front of the fireplace would help out significantly.
Thank you.
Very good. Anybody else have any questions? Looks like Mark's got another one. Do you have plans or information about constructing dedicated electrical supplies to an audio system?
Yeah. So yes, absolutely. That's something that is going to be unique to your situation. So it's not just I did give out earlier in the presentation the general rules to follow, but your system is going to be different from Larry's system as far as recommendations and what's needed. And so, yeah, I mean, that's one of the services that I provide. So I can learn about what your system exists, you know, what you have, and or what you're planning on, and offer recommendations for that. And or if you've got particular issues, this is not something that I can do without being there. But if you've got particular electrical issues, then I can come out and measure those and investigate and find out what is needed as far as solutions. Again, electrical is so weird. It's every like reverberation times, I guess, you know, it's unique. Everybody's system and everybody's scenario and even the time of day can have an influence on the power quality.
Good. All right, well, this has been an excellent presentation. Sure appreciate your time and allowing us to meet with you.
Sure, anytime. We can talk about anything acoustical or electrical in future presentations.
Very good.
Yeah, it's never ending.
Yeah. Yeah, very good. Well, thanks so much, Norm. We really appreciate it. And
Thank you.
we'll get your PowerPoint and video up on our website. And that's great. Yeah, we're getting some people expressing their appreciation and thanks. So it's been
Cool.
great.
Well, thank you. I appreciate it very much and look forward
All
to
right.
doing it again in the future and hopefully helping out some of you guys with acoustical or electrical problems.
Great. Yeah, I think you'll be having some people get a hold of you.
Cool.
Very good. All right. Take care.
Mr. Varney, it was as much a joy to speak with you or to hear you speak this time as it was to meet you down at the show. And I look forward to doing business with you.
All right. Well, thanks, Mark, and me too. And maybe we'll see you at the next show.
Yeah, fingers crossed. Although
All
I might not have money for that because I will have spent it all with you.
Okay. All right. As long as I'm first.
Okay.
All right.
All
Thanks,
right.
guys.
Thank you.
All right.
Bye.
We'll see you.
See you, Norman.
Yep.